Okay, the k is defined below. So this is his k, right? Okay, so his assumption is this, but I want you to work out in holidays because there are ambiguity here. This function of z, is it real or is it complex? So after this, I let you, you need to do in holidays to find out which one is correct. Because there is nothing said here. Okay, so we use this wave equation. So that's why you see here, I put the e in front, but there is an extra e squared over m here. So we need to modify our wave equation. We multiply every term with e squared over m. So this term here, and this term here. So is it make sense to you? So if we do like this, so means that after this, okay, after this, this part have the time derivative. So this is the wave equation. When we substitute the field, we need to substitute the amplitude with the z dependence, and also with the z dependence of the p. All right, but the time dependence always in exponent minus I omega t. So we substitute the e with this into here. Here also. So this is the one we need to substitute here. So this is the modification of the wave equation into this. I copy and paste here. So I substitute the e into this. Right? The e here into this, and the p into this. Okay. So when I work it out, this one is del over del z, something special derivative. It won't affect the time function. So we do like this, but the time derivative will operate on this. So we have minus omega square. So this term, after we take the time derivative, we have this minus omega square. And then the time derivative will gone. I just work it out slowly. So you have this, when you work out the time derivative, you have this minus omega square also. Right? So you left the like this. And then every term carry this, right? So you can see if you feel not so confident when you want to do anything, you try to color first, make it color first. So left and right of the equation, every term carry this. So I can delete this color. So this is what we get. So I name it as equation 2. Equation 1 is from the paper. Okay, so we managed to obtain this. And then this is our second result after we take the delete the time derivative. So I can delete this because just to show you the step. So this is after consider the time. So whatever left over all depends on z only. Depends on z only. There's no more time already. Okay, and after this, if we want to solve this, okay, you can see this. This green part. So this green part we substitute from equation 1. So this, is it the same? The green one? So substitute this. So if you substitute this, this is what you see. This one, the first green term, the second green term is here. Okay. And then this one leave unchanged is here. And after this is simplification. So how to simplify? Let me see. Okay, so there is omega square mu naught epsilon naught. Okay, here is just omega naught mu naught. Omega square mu naught. So I want to put the epsilon naught. So I must divide the epsilon naught. So effectively I do nothing. I just want to change its appearance. Because omega naught, omega square, no, mu naught epsilon naught is 1 over c square. So this term is omega square over c square. So this term is omega square c square. Am I doing it correctly? So the del square here effectively is double derivative of z. But right, del square is d square over dx square, okay, plus d square over dy square and so on. But we just let the p or the e has the spatial z dependence. So the del square reduced to this. This one is actually double derivative of respect to z. So if we spell del square with this, right? So we have this. So this one operate on here is d square p over dz square. This one operate on this, you have this. Okay, the triple p is inside the curly bracket, and then this term doesn't change, right? This term also doesn't change. So is it okay? So far so good. Give me your response. Yes, you managed to capture. Okay, so because to make sure that you have a good record, you can take video record or you can snap the photo. You know why I cannot send you? I cannot send you this because of, you know, this is your project. But I should not give you too details also, right? But I know your difficulties because of you haven't take many courses yet, especially 304. You haven't take 304 yet. You are going to take 304 next time. All right, so I just show you some details, and then after this you work it properly lah. Right, so here just let you see some steps. This one we have no problem. Okay, we have this. Later we have to expand. According to the articles, this differentiation of three terms like this. So effectively you have this. Work it out, see whether you get the same answers or not. So this is like the chain rule. So this term, you get this term. And then this term, we do not differentiate, they remain the same. All right. And after this, okay, so this term, actually, I do one of the derivative first. This one not yet done. So d square over dz square is double of this. So this term is because of this. I take this of the operation. There's still one more. So if I take the second one, so this one, when you differentiate, then you get double of this. So this one remain the same. P square remain the same here. And after this, you differentiate this p square. You have 2p dp dz. You differentiate this respect to z. You have 2p dp dz. Multiply with this thing unchanged. So it's like implicit rule. Okay. And then this term, when you differentiate. So this one, one thing, this one another thing, this one another thing. So you have three terms. So the first you differentiate respect to z, you get this d2p over dz squared, this unchanged. And after this, you